Hello everyone. Today's topic is going to be on thyroid gland physiology. We're going to be starting this lecture by going over the basic physiology of how the thyroid hormone is actually made in the body. In the hypothalamus, which I want you to focus up to the brain up here, I want you to know inside the hypothalamus is where your what? The thyroid releasing hormone is made. That's TRH. That's extremely important that you know that. Because this thyroid releasing hormone, which I want you to pay attention to the words that we use in medicine. Thyroid, right? T, releasing, it's going to release a hormone. So that's the goal. It's going to go down and flow down into the pituitary to tell the pituitary gland, wait a minute, let's make something. What is that something going to be in the anterior pituitary? It's called the thyroid stimulating hormone. Now, wait a minute. If this is a thyroid releasing hormone, because we want to release something from the thyroid gland, and this is not a thyroid stimulating, something's going to stimulate the hormone, like, wake up, we need to make something. It's going to go down and now stimulate the thyroid gland, which is made up of a lot of follicles, a lot of follicular cells. And the job of the thyroid gland is to make what? Thyroxine, which is T4 or T3. Now, we're talking about physiology, so now I've drawn how in the world did we just make T4 and T3? It's magical, right? Because at the end of the day, this is the end product. Now below, I've drawn down what a thyroid follicular cell looks like. So this is how the thyroid hormone is made, which is thyroxine. Initially, you need iodine. That is the key element that we need. Do you know why we need iodine in our diet? Because we need it to make thyroid hormone excruciatingly important. Without it, we can't make any thyroid. And we're going to talk about pathophysiology later of thyroid pathologies when we get to the next lecture. So follow this pathway, very easy. I stands for iodine. Now, iodine usually comes negatively charged. It's an anion, right? But first, we need to trap it. So basically, if you're eating your salt in your diet, whatever, you get it from food. And now the iodine has to be trapped. They come in, the iodine is kind of minding his own business, and bam, it gets grabbed. Once it's grabbed by the epithelium of the follicular cells. Now the epithelium like, come to Papa, I know, we need you. Why? Because thyroid stimulating hormone is telling the thyroid to make thyroid hormone. So when iodine is trapped, we need to oxidize it. So the first step is what? It's called trapping, which is done by the iodine pump. Kind of wonder, right? Something that has to get iodine, it has to be a pump. So it's called the iodine pump, right? So iodine pump, however, the iodine that's actually ionized has to be oxidized to form an I2. Now there's an enzyme that has to do that. That enzyme is called what? Iodine peroxidase. Iodine peroxidase. You have to know this enzyme. You must know this enzyme. Because at the end of this lecture, I'm going to throw in a little bit of clinical pharmacology so you can see why it's so important. Because we're going to be talking a lot about this enzyme. Once we have an oxidized, which is I2, iodine, now this is all happening in the what? In the cell membrane of the thyroid follicles. T is thyroxine. What is tyrosine? Tyrosine. Tyrosine is an amino acid. Now, I might not necessarily get the structure of tyrosine right because I don't care. But it's something that looks similar to this. This is not necessarily the structure of tyrosine, but I'm just giving it a shot because it doesn't matter what the structure is. I'm just using it as an illustration. However, this is an amino acid, right? It has the amino group, right? It has the carboxyl group. Now, tyrosine, which is an amino acid, is going to be stuck to thyroglobulin, which is a protein on the ribosomes of the follicular cells. Now, we need to add this iodine to this tyrosine. And all we have to do is take an iodine, right? And add it to the tyrosine molecule. And we're going to use this whole structure and make it a T. But what actually is happening is that process is also done by what enzyme? Iodide peroxidase. See how important that enzyme is? The same enzyme that did what? It did the oxidation reaction of two iodine molecules coming together, right? Now, we're going to get a T1. It's not really T1, it's just an iodinated thyroxine. Can you see here how I put a little I on top of the T? That process is called organification. So let's keep the step straight. We pumped in by trapping. The second step with oxidation reaction. We got two I minus C's, right? To get an I2, right? And now we're gonna organification, which is a fancy word for taking the iodine and adding the tyrosine amino acid to form MIT. Well, it's not Massachusetts Institute of Technology. This is called mono, means one, iodotyrosine. Remember in medicine I always tell us to break the words into three? Mono means one iodo, which means I'm adding one iodine molecule to the amino acid. Now I have MIT. Guess what? We can also have two molecules of this to the tyrosine molecule to form this. Now we have two iodine molecules. This is called DIT. DIT will look like this, which stands for di, which means two, iodotyrosine. So now we've done the organification steps. See how easy it is? You take an iodine molecule, we trap it, we bring it in, we bind it to a tyrosine molecule, which is on thyroglobulin, using the same enzyme, IPL, iodide peroxidase, to form MIT. Now, I used to memorize this thing and I used to wonder, my God, MIT, DIT. Well, it's cool to memorize that, which is nice, but there's another step left. If you not take one MIT and a DIT, we form a 3IT. No. Yeah, it's kind of like 3IT. We form T3. So if you take one MIT and a DIT, we form a T3 molecule. So you know how you just remember it? If you just know how to count, because this is just one iodine molecule plus 2 equals to 3. Wow! That's all you need to know. 1 plus 2 equals to 3. That's how we made T3. MIT DIT. If we take 2 DITs, we form what? 4 DITs. 4 DITs is the same thing as what? T4. If all you know how to count is 2 plus 2 basic math, you get a 4. That's it, guys. Very straightforward. That's how we made T4 and T3. Now, T4 is thyroxine. When you have only one less of, this is tri-iodotyrosine. What we think T4 is? Tetra-iodotyrosine. Now, when all the freeze process is nice and done, and we've finished this last step, and this step is doing coupling two things together, so that step is called what? Coupling. It's having two couples. This is couple 1, the male and the female. You take them together, you form a nice little baby, but the baby is now T3 and T4. That is also done by which enzyme? Tell me. I know you know it. IPO, iodide peroxidase. Do you think that enzyme is very important? I bet you think it. It is. Now, those are the 4 steps. What's going to happen next? Now we've made T4 and T3. We got to store it. It's very important that we store it. How do we store it? Now, this thyroglobulin, right? Remember thyroglobulin, the same protein? It's going to grab this guy and put it on his backpack. So, this is thyroglobulin. You know, and inside thyroglobulin is T4 and T3. T4 and T3. This is thyroglobulin. We're going to go into the lumen, which is something I drew here of the cells, and store it in there. Because when the time is right, we're going to have to release it. So what's going to happen? When it's time to now make thyroxine, which is the thyroid hormone, all TSH has to do is TSH tells the thyroid gland, make some T4 and T3. So what do? We have to release it. The way we release it is we cleave off the T3 and the T4, and we release T3 and T4 into circulation. Beautiful. We release them both into circulation. But when they get out into the real world, they're like, oh my God, I don't know where to go. I don't know where to go. Guess who's waiting for them? The liver noticed these little babies don't know where to go. So it needs to jump on a bandwagon. And that bandwagon is called thyroxine, from the hormone binding globulin. Simply a protein. We don't like this just for our body. Our body, we got to pre-package them. So some of them are going to bind to TBG. Now, this can get really confusing because this is TGB, right? Completely different. Thyroglobulin is inside the thyroid follicles. Inside your serum, inside circulation, thyroxine, now that we've made it, is now going to have to bind to a globulin, which is a protein that's made by the liver, so that it can carry it around to the tissues and say, hey, tissues, we got to use you. Now, something important you need to know about T4 and T3. When T4 is released into circulation, it's going to go into the tissues. But when it gets to the peripheral tissue, it's got to be deiodinated by a protein called what? 5' iodinase. And make the active form of T4, which is T3. T3 is more active than T4. We haven't even talked about the function of thyroid hormones yet. But this is what's going to happen. T4 is going to convert into T3, and then the T3 can go into the tissues and kind of do what it has to do. We can also make a reverse T3, which is an inactive form. It's not really going to do anything. It's just going to be hanging out there. But that's another form that can also be made. But when we make T3, remember T3 is the most active form of thyroid hormone. Now, something needs to be talked about here. Although T3 is biologically more active, what exactly is it doing when it gets inside the tissues? When we get into the tissues, what is the function of T3? Which is basically the thyroid hormone. Now, this is how I remember thyroid. I think thyroid is the hormone that it kind of does everything. What is everything? What do we call everything in medicine? I call it metabolism. And it's just not metabolic, it's actually a catabolic hormone. It breaks a lot of things down, it kind of makes everything go right. Now that's two general and fancy words. So we're going to break it down one by one. The first thing you need to know is growth. Apparently we need to grow. I didn't know that. Oh yeah, it's true. You got to grow. You're not the same little Johnny when you're 2. Now you're what? You're 7. You're a big guy. Now you're 25. Oh wow, you get big guy too. Now, it's important that you know that thyroid hormone is going to synergistically bind with the growth hormone. And what does the growth hormone do? It allows you to grow. So T3 is always hanging out with growth hormone so that you can grow. That is needed for growth. What do we need to grow? Bone formation. That's extremely crucial. Now, another thing you need to know about the function of T3 is CNS. Now, when children are born in the hospitals, we always want to make sure they are not hypothyroid. The reason because the brain needs the thyroid hormone actually gets the brain regulated so the brain can actually mature. So if you don't have any thyroid hormone, you're going to be mentally retarded. So it's absolutely important that you have the thyroid gland working once you're born so that the CNS, which is the central nervous system, is your brain and your spinal cord, they need to be developed and mature. Now, if you don't have T4, T3, become mentally retarded. So at birth, neonates, they always get screened. What else do we need it for? We need it for the autonomic nervous system. I thought this was the most fascinating part. Autonomic nervous system. Where's the autonomic nervous system? The sympathetics, right? Parasympathetics, right? But in this case, thyroid hormone actually stimulates the increase in beta-1 receptors on your heart. All over your body, you have beta-1 receptors. So now if I release a lot of norepinephrine and they bind to your beta-1 receptors, what's going to happen to your heart? Your heart rate is going to go up. What's going to happen to your cardiac output? Your cardiac output is going to go up, right? So we need this hormone to function. That's why I'm going to talk about quickly pharmacology, why we use beta blockers when patients have hyperthyroidism. Because if you have too much T3 and T4s floating around, you increase the number of beta-1 receptors, right, on the peripheral organs, then your blood pressure goes up, your heart rate goes up. So if we give you beta blockers, we can block, right, we can block these receptors with propranolol, which is a beta blocker, so that your heart rate doesn't go up, your blood pressure doesn't go up, and all those other symptoms of hyperthyroidism. That is a very good clinical pearl. Now, aside from that, we also need the thyroid gland to maintain our basal metabolic rate. Basal metabolic rate. What the hell is that? Well, basal metabolic rate is basically oxygen consumption. What do we need oxygen for, guys? I told you in the electron transport chain, you need oxygen at the bottom so that you can what? You can form ATP. So we don't need, if you don't have ATP, all the what? Sodium, potassium, ATP is pumps in our body. They're not going to work, and if they don't work, the cells are going to die because you need to maintain that balance between sodium and potassium, right? You keep a lot of sodium outside, you keep the potassium inside, electroneutrality. Or else the cells are going to swell up, it's going to shrink, something's going to happen, this is not going to go right. So that's metabolic state. So because of oxygen, basal oxygen consumption it's extremely important for human beings to stay alive. We need that oxygen for the electron transport chain to receive those electrons and make water, make all those nice little electrons, all that stuff you learn in basic biochemistry so that we can stay alive and make ATP. It's all under the influence of what? The thyroid hormone. So it's very important because we need this oxygen for our tissues. And if the tissue doesn't get oxygen, we get what? We get lactic acidosis, we get ischemia, the cells start to die. Also, you think we're done with that. Last but not least, we said metabolism, right? Well, what is metabolism? We got glycogenolysis, gluconeogenesis, lipolysis, right? Protein synthesis, Now, guys, glycogen, no lysis, means lysis of glycogen, which is a stored form of glucose, so we can break down glucose. I think we need glucose for our body, right? The brain needs glucose, the heart, the muscles, they all depend on glucose. So the thyroid gland is making sure your body is breaking down glycogen when you need it as a backup. Gluconeogenesis, right? When we need to crank up new glucose, either from, we can use lipids to make glucose, right? Using like fatty acid, that's the possibility. I don't know, we taking, pyruvate, reversing the reaction, right? Making gluconeogenesis. Now, if those reactions don't happen, we can't make glucose. It's very important that you remember that. Now, lipolysis, breaking down of fatty acids, right? Fatty acids can be used by your heart, can be used by your brain. Ketones can be used by the brain. All these beautiful, gorgeous things to keep our body homeostasis constant. Protein synthesis, we need to make a lot of proteins. A lot of hormones are proteins, right? Albumin, all that good stuff. See how important thyroid gland is? Yeah, that's exactly why we really, really need thyroid hormone. So in summary, as you can see, if we had to take all this and condense into one thing, we can say the thyroid gland is needed for growth and metabolism. That's it. That's it. That's the bottom line. Growth, metabolism. CNS maturation is growth. Basal metabolic rate, all of this stuff is all metabolic stuff going on in our bodies. So now that we have understood the function of the thyroid gland, how it's made, the next thing we're going to go into, which is the next lecture, is going to be on the pathophysiology of what goes wrong here, or here, possibly, right? That can cause patients to become hyperthyroid or low thyroid, which is hypothyroidism. Watch out for the next lecture on thyroid pathophysiology. I hope you really enjoyed this lecture. And just to summarize, like I always do at the end of my lectures, hypothalamus makes TRH. TRH is thyroid releasing hormone, telling the anterior pituitary to make thyroid stimulating hormone at the end of the day to make T4 and T3, which is responsible for our growth and development. Thank you very much for watching. Watch out for part 2. Have a great day. Bye-bye. Hey, thank you so much for watching the video. I hope you learned a lot. Are you studying for the USMLE Step 1 or Step 2? Are you studying for the NCLEX, or you're currently in nursing school as a nursing student? Are you a PA student currently in school or studying for your PANCE exam? Or are you a nurse practitioner student or trying to take your NP board exam? Listen, I've got super awesome content for you. If you truly love this video and it simplified your learning process, I want you to check out my website below. I've listed all the list of exams, whether you're studying for any of this board exam, and all I want you to do is click on the link right now below so that you can take you directly to my website. For USMLE, just go to smashusmle.com. For NCLEX, go to crushnclex.com. And if you're studying for the PANCE exam, the nurse practitioner exam, or you're studying for your internal medicine board exam, just click below and it'll take you directly to ftplectures.com. Listen, I can't wait to help you. If you need to get in touch with me, just get to my website, be able to reach me directly, and we can work together one-on-one. Listen, you're super awesome, and my goal here is to help your dream come true. If you want to be a doctor, want to be a nurse practitioner, a registered nurse, or physician assistant, I'm here to help you get to that next level. With your medical knowledge, let's save the world together. I love you guys. You guys are super awesome. And do not forget to click on the link below to be able to get to my website. Also, don't forget to subscribe to my channel. You guys have a great day. Let's go.